expectation of a random variable. Suppose you have a random variable. If x is discrete random variable having a probability mass function px, then the expectation of a random variable x, or the expected value of x, which is denoted by e of x, is the summation of all x times px. And if x is continuous, you can change this to the integral negative infinity to infinity of x times f of x dx. So f of x is going to be probability mass function for the continuous random variable. Please remember that using Riemann sum, as we increase the number of bars, we get a better approximation for the area below the curve. So this is basically what we'll be doing. When you have a discrete random variable, that variable is countable. So we expect to have the summation of x times the probability of x. But as we increase the number of bars, it means that the distance between variables on the horizontal line, the values, it's getting smaller and smaller, and you get a continuous random variable. So this Riemann sum becomes the integral. So far, we learned about the expected values. If x is discrete, it's just a Riemann sum of x times px. And if x is continuous, then you have the integral of x times f of x dx. Now, the interesting part is the expected value of a linear combination, ax plus b is a linear combination, is equal to a times the expected value of variable x plus b. So the expected value of b is equal to b, and the expected value of ax is equal to a times expected value of x. The expected value of a random variable like x, e of x, is also referred to the mean or the first moment of x. Please note that you can calculate the expected value of x to the n, and it is called the nth moment of x. The calculation is very easy. If x is discrete, the expected value of x to the n is the summation of x to the n. So you just switch x and x to the n times px. And if x is continuous in your integral, instead of x, you're going to use x to the n f of x dx. The next important topic is the topic of the variance. For any random variable, we are interested in finding the expected value and also the variance. Let x have the probability mass function px, an expected value mu. Then the variance of x, which is denoted by variance of x, or sigma squared of x, or sigma squared, is the summation of the deviations from the mean to the second power times px. This happens to be, it is the expected value of x minus mu to the second power. Another formula for you. So the variance of x, which is denoted by sigma squared, is basically the summation of x squared times px minus mu squared, or exact value of x squared minus the expected value of x to the second power. So in solving problems, sometimes it's easier to apply this formula or this formula. So depending on the question, we can apply different variance formula to do the calculations, and it makes it a little bit easier for us. So now that we learned about expected values and also the variance for each random variable, we're going to jump into different random variables and calculate their expected values and their variances.